everyone. So today we are having this course of ROS navigation, which I'll introduce and some basic concepts we'll look at now. So first of all, we are using this Robot Ignite Academy platform to easily learn about the ROS, and it will be really fun using this platform as you'll see now. So let me just go through the whole process very quickly. We are going to see a Jupyter notebook on the left hand side, and where we'll learn about the theory, and we'll see all these summary and practice exercises, examples, etc. on this, which will help us in applying all the concepts. And on the right hand side we are seeing the actual ROS platform, which is basically a Linux based platform which we'll be using. Here we can type commands whatever we want to, and you will see the simulation up here. So whatever robot you are seeing here will be the actual robot in the real world. Since we want to reduce our time and don't have a actual robot, we can use a simulation instead of it. And in between, this is the file manager, which is there on a Linux system, which can be controlled through this command window, where we can add or remove files which we are going to use. So that's the small structure we have, where we'll be doing different commands in these windows and noting their responses in the simulation. So let's get started. So here, as we see, we have the summary that we need to give it 2 hours to complete this chapter. There are few more chapters which you will see down here. So we are starting with basic concepts. The next is a guide for ROS navigation. Then we'll be diving into mapping, localization, path planning, and in the end we'll be having navigation project. So for this chapter we'll be seeing about what is ROS navigation stack, why what do I need to work with this navigation stack, and why is it so important, and in the end how this ROS navigation takes place using move based node. I hope you know some basics about the ROS and how it works. If you don't, please go through the any course with basic introduction of what is ROS before this video. So let's get started now. The first question that comes to anybody's mind is, why do I need to perform navigation with ROS for any robot? Um, Even before going through how it is done, let's answer why do we need to do any navigation. For any robot, moving from one point to another is very important thing, since it cannot see, it doesn't have human mind, it cannot understand what is an obstacle and what is not an obstacle. So we need to program this navigation to in this robot so that it can uh, navigate and not hit this part if it wants to go from this point to this point. Plus it needs to find the optimal path in which it saves its time and takes the shortest path. So yeah, that is why navigation is the most important part of any robot which is moving, obviously. So we know navigation is important, but how do I do it? So the very first thing which we need to do navigation is A map, obviously. So as we are using our mobile devices or our laptops to see Google Maps or any other map when we have to plan to go to an unknown location. For a robot, everything is unknown, right? It doesn't have a very uh, good mind like a human, so it needs a map every time. It needs to know where it wants to go and what are the obstacles which keeps on changing with time. So we need a map, okay, but how do we get this map? So for that we need to get a sensor to make it map for it. First of all, let's see what this robot is doing to get that map. Every robot has its own procedure of getting a map, but this one, which is right in front, I can maximize it here so you can see properly. This robot platform is called Kobuki, and this has different sensors on it. One of them is called Kinect sensor, which is right here. If you can see, yeah, this one is the Kinect sensor, and this one is a lidar sensor. Using these two sensors, it can generate a map of the environment using IR readings. So as this robot moves around, the sensor uh, gives feedback to its memory and generates a very good map. And now we'll see how it's actually done. So to do this map formation, we need to launch couple of commands, which we'll do right now. So first command which we need to type in is this one. So it's called gmapping demo.launch, which we are going to use. So we'll copy and paste it here. So what it does is it opens a couple of programs which moves which actually updates the map using gmapping algorithm as the robot moves around and generates a map. So next thing is we need to actually move it around. So for that we need to do this command. So this is a keyboard teleop command which will move this robot with the use of our laptop keyboard or whatever platform you're using keyboard. So as you can see here, if there are a couple of instructions which you can read which will help you in moving this robot around. So for moving this robot around, we'll need U, I, O, J, K, L, M, this and these keys. To make it simple, we have a little small table which says it moves forward when you press button I and turn left when you press J and so on. So let's try it now. So if I want to move this robot, I'll just be on this window and I'll press I, it starts moving. If I press J, it will start rotating. And now we can control this robot. But wait, I cannot see any map since I said I'll be having a map now. No, we need to do one last thing to actually see the map. It's called Arvis. Arvis is a platform which we need to use to see any kind of an output which is GUI. So we launch this using this command. There is a particular configuration that we have, which we have stored, which we have to view the map. And let's open this graphical interface. So yeah, now we have an actual map. Voila. So we can see this map has been generated, which is not actually a complete map, but since we didn't move around the robot very much, it has not been completed yet. To complete this robot, we need to go to every point which needs to be in its range, so that we can see each and every location first and store the whole map in it. So we'll try to go to each and every location. This part is unknown for us, this part is unknown for us, so we'll cover all of them to generate the whole map. Now let's do it. Remember, you need to be on this window to in order to be able to control the actual robot here. So let's see if we can go to the left part now. Yeah, let's zoom in a little bit. And since it's so slow, I'll try to increase the speed by pressing Q. Yeah, don't increase it too much, else it will lose its sensing. So basically we use three things right now. First thing that we used was the this command gmapping demo, which specifies what algorithm to use, what method to use to make the map using the sensor readings. The second command that we used was keyboard teleop, which moves this robot at various location using the keyboard commands. The last thing that we used was the view mapping command, which launches a RViz window in which we can visualize the output which we are getting as a map. So our map got a little bigger now, as we can see here. And these, okay, let's just go back now. So first activity was about how to create a map, and we did it. So what's next then? We have created a map, but we need to localize the robot now. So we need to not only make a map, but as we use our Google map or any other map, we also need to use the location also. Remember, like where exactly is the person or the robot standing in the map. You need to be very sure about that in order to go from point A to point B. In a sense, you need to find out the point A to plan the path to point B. That is what is called localization. So the next step is actually localizing the robot. We'll learn about this step in the next video. So we can first practice the mapping part in this video, and come back for learning about how to localize the robot in a map.